So yeah, we have a poster which presents several projects going on in our software reliability group here at Imperial College London. So one research direction which we're really interested in is to make symbolic execution scalable for evolving software. So basically, as the software is being changed, how can we actually incrementally, apply symbolic execution in that context? We have two ongoing projects that try to address this. One of them is automated chop symbolic execution, where we try to automate this idea of skipping irrelevant parts, parts of the code which are irrelevant to a patch. And Martin will give a talk on this tomorrow as well. And then we are exploring using product programs, which are typically used to reason about non-interference properties in a security setting, to try, instead to reason about multiple versions of a program within the same symbolic execution instance. Another line of research that we're interested in is to have these long-running and deterministic symbolic execution runs. So we have two projects that we're presenting in our poster. So one of them is on memoized symbolic execution, which was presented in the past, I believe last year, right at the KLEE workshop as well. And the idea was we have this technique that allows this forever, runs of symbolic execution in such a way that whenever you run out of memory, you can save the current run to disk, and then you can incrementally bring it back into memory as needed. And then we have a project on deterministic memory allocation, which benefits several techniques, including memoized symbolic execution. And we are building, we have built a memory allocator specifically designed for symbolic execution, which is both cross-run and cross-path deterministic, also maximizes the probability of finding certain types of memory bugs, and keeps a low memory and performance overhead. We will have a talk by Daniel shortly coming just before lunch. We're also working a lot on exploration strategies. So one project that we have is on pending constraints, where we try to aggressively prioritize paths for which we already know that were already solved via caching or via seeding, and defer all other pending constraints. Again, we'll have a talk on this by Frank tomorrow. And then also in this line of exploration strategies, so, we apply this in the, we are trying to confirm static analysis reports. So the idea here is to guide the exploration to follow the trace in a static analysis report. And of course, if successful, you are confirming the static analysis report, and we also have an input that demonstrates the bug, and we can tell you more about the issues, our experience with applying this technique and the issues we encounter. And we have a poster talk by Frank after lunch today. And finally, we have this work on approximating floating point via fixed point. As you know, SMT solvers are notoriously slow for floating points. So, the idea is whether a fixed point approximation is precise enough. So we're also aware that another group, in fact, you're going to see a talk at the workshop on this fixed point approximation. And of course, we are in touch about that. I think our approach is a bit different, because we defer fixed point reasoning as much as possible, with concrete operations staying in the floating point domain as much as possible. So this project, all these projects, I think several different projects, are on our poster, and we're looking forward, please talk to my group, to me and my group, about them.